Okay, you guys, today we're doing lesson 414. We're going to be identifying proportional segments within triangles and extending triangle proportionality when you have parallel lines. Let's take a look at the warm-up. Number 1 says, write a similarity statement for the two triangles in the diagram. Why are they similar? All right, so when you take a look at this, you can see that you have a smaller triangle within the larger triangle. So that's what they're talking about. They're talking about these two triangles, the small one and then, of course, the larger one. And when you look at this, you can see that those lines have arrows, which means technically that these lines are going to extend, okay? And when they do, that's parallel lines, and that means this line coming through here and this line coming through here will be transversals, and so then you have the host of angle relationships there as far as having congruent angles. And because of the transversal coming through here, angle A and angle Y would be congruent to each other, and then because of the transversal coming through here, angle B and angle Z would be congruent to each other as well. So that's 1, 2 set of congruent angles. So the reason that they are similar will be what we covered in our last lesson, which is angle-angle, and that angle-angle similarity. And then to write the similarity statement, you would put triangle. I'll do the smaller one first. AXB is similar to, and remember that's the symbol for that, triangle. And then remember, it doesn't matter the order on the first one, but it does matter on the second one. So the angle that is congruent to A is Y, so that would come first. X, of course, would be second because it is congruent to itself, and then Z would be the last letter. All right, now it tells me if XA is 16, so that's this piece right here, and XY is 18, so XY is the larger triangle, and then XB is 32, that's the smaller triangle. Find XZ. XZ would be this side of the larger triangle. They're wanting you to find XZ. So you would just set that up with a proportion. And it doesn't matter exactly how you set it up. I'm going to set it up with using the two sides of over on this side of the triangle and then this side of the triangle, although there could be several different ways to set that up. So I'm going to put 16 over 18. That would be a constant. And then, because I put the smaller over the larger, I would put the smaller over the larger. So I'd put 32 over XZ. Now, like I said, there's a variety of ways you could set those up. Just as long as what you do on the left, that's exactly the way you set it up on the right, you're good to go. And then you would just cross multiply through here. 18 times 32 would be 576 equals 16xz. Divide both sides by divide both sides by 16. And xz equals 36. So now you know that xz is going to be 36. All right, now it tells me if yz is 27, find AB. So yz is the bottom or the base of the larger triangle, and they say that it's 27. So they want me to find AB, which would be the base of the smaller one. So there are different ways that you could set that up. I'm again going to use that same constant of 16 over 18, which again is the smaller over the larger. So that's the way I would set it up on the other side. The smaller, AB, over the larger, which would be 27. Cross multiply, 18AB equals, and then 16 times 27, 432. Divide both sides by 18, and AB equals 24. Okay, so this would be 24. All right, now it tells me to find AY and BZ. You don't have to set up a really large proportion to do this. If you know that the large side is 18 and then XA is 16, they want you to find AY, this piece right here. 18 minus 16, that would be 2. So AY is 2. And then to find BZ, if this full side, the larger side is 36, and then this smaller piece is 32, 36 minus 32, that would be 4. So BZ would be 4. All right, let's talk about triangle proportionality. Think about a mid-segment of a triangle. A mid-segment is parallel to one side of a triangle and divides the other two sides into congruent halves. The mid-segment divides those two sides proportionally. Example 1. A triangle with its mid-segment is drawn below. What is the ratio that the mid-segment divides the sides into? So this is what they're talking about. You know, you have your midpoint here, and we've done this in earlier lessons, where you measure and then you find your midpoint, and you measure over here and you find your midpoint, and then when you connect those two midpoints, that's your mid-segment, okay? And in this case, this mid-segment divided it to where you have 8 on the top and 8 on the bottom, and 10 on the top and 10 on the bottom. So when it asks what is the ratio, that would just be 8 to 8, which would simplify to 1 to 1. Okay, same if you did 10 over 10 or 10 to 10, that would simplify 1 to 1. And yes, it's okay to have 1 as your denominator with a ratio. You're expected to have 2 numbers there because you're comparing the 2 numbers. Okay, so your ratio is 1 to 1. You could also write it as 1 to 1. Either way, that would work. All right, the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. Now, this is what that is saying, okay? In other words, you'll set up a proportion here to where you could have BD over DA, okay, is going to set up proportionally to BE over EC. Okay, so that way when you go to set up a proportion, say, just like a moment ago, we were looking for a missing side. As long as you have a constant on one side, you can find a missing measurement on the other side because of the fact that it does set it up in a proportional format. And once you do some examples, you'll see it's a little bit easier to understand. Okay, now the triangle proportionality theorem does have a converse of that, okay? And it simply says, remember, converse just kind of switches the order. If a line divides two sides of a triangle proportionally, then that lets you know that the line is parallel, okay? So, for example 2, it tells me in the diagram below, EB is parallel to BD, okay? So here's EB, and it tells me that it's parallel to BD, that must be CD, oh goodness sakes, to CD. So these lines are parallel, okay? And then it wants me to find BC. So I have this measure, I have this measure, I have this one. This is the one they're wanting me to find right here is BC. So when I go to take a look at that, I'm going to use these two as my constant, okay? And I'm just going to put 15 over 10, because just remember, if you set it up one way on the left, just be sure to set it up that exact way on the right, and then you have a true proportion. So if I put 15 over 10, I'm going to put 12 over BC. And then you simply cross multiply to solve for BC. So that would be 120 equals 15 BC. Divide both sides by 15, and BC equals 8. So this would be 8. All right, now on example 3, it says, is DE parallel to CB? So they're wanting to know. Now this was where the converse comes into play. This time they're saying, okay, we have these numbers. Does that make these parallel? And that's what you have to do. You have to check to see, does it wind up being proportional, okay? So there's 2 different ways that you could do this. One of them is 18 over 6 equals 24 over 8. Okay, you could do it, that's one way that you could do it, okay? And you could then, lost my calculator, here we go. And then you can take it through there and cross multiply and go through here. 24 times 6 is 144. 18 times 8 is 144. That's one way to do it, okay? And I'm just going to go ahead and show you the other way. You could also do 18 over 6. Simplify that to 3 over 1. And then 24 over 8, which would also simplify to 3 over 1. So when it turns out to have the same number, or when you cross multiply and you have an equal proportion, then that lets you know, yes, these lines are parallel. Okay, parallel lines and transversals, which we discussed transversals in Unit 3. But this says we can extend the triangle proportionality theorem to multiple parallel lines. Now don't panic because you see this. I know instantly you're going to want to panic. Don't panic, okay? If 3 parallel lines are cut by 2 transversals, then they divide the transversals proportionally, okay? Which means you could set them up in a proportion, and as long as what you do on the left, you set it up the same way on the right, cross multiply, you can find a missing number or a missing measure, okay? So for example, on example 4, you have A here. They want you to find A, and here's 20, and here's 9, and here's 15. So I have the 2 measures here. That's going to be like what I call my constant, okay? So I'm going to do 9 over 15, okay? Which means when I set that up, if I do 9 over 15, that means on the other side, I'm going to do A over 20. And then you just cross multiply. 15 times A, 15A, equals 9 times 20 is 180. Divide both sides by 15, and A equals 12. So this missing measure would be 12. So it's not hard at all. Don't panic. All right, let's move on now to example 5. Yes, there's quite a few there, but it's still the same process. Okay, you have the same process. You have 12 and B. They're wanting you to find B, and you have 9.6, and you have 24. And like I've said, just be sure the way you do the left is the way you set up the right. You're good to go. All right, so I'm going to set up my constant first, and I'm going to put 9.6 over 24. This one on top of this one, which means I put 12 on top of B. And then just cross multiply. 24 times 12 would be 288 equals 9.6 B. And then just divide both sides by 9.6. So B equals 30. All right, now for example 6, this tells me find the value of X that makes the lines parallel. Okay, so don't panic here. You're still going to set it up the exact same way. It's just you're going to have to solve for X. Okay, you're going to have to do that. So I'm just going to put 5 over 8, which means 3.75 over 2x minus 4. And just remember, you kind of think of that as doing distributive property, okay? Just don't panic there. Just take your time. So 8 times 3.75 is 30 equals, and then do distributive property here, would be 10x minus 20. All right, now you just work it just like a regular equation. Add 20 to both sides. You'd get 50 equals 10x. Divide both sides by 10, and x equals 5. All right, now example 7. Yes, I know that's a lot, okay? Just take your time on it. They want us to find A, B, and C, okay? So what you're gonna have to do is just take a look at that. If it freaks you out because you got so many there, cover part of it up. Like I could use my eraser, okay? Just cover that part up. Here you have 9 and 3. Here you have A and 2. And that's all you need. You have your constant. You can set that up to solve for A. Then you can put that number there. Then you can work your way down, okay? But here's your constant. I'm going to do 9 over 3 equals A over 2. Cross multiply. 3A equals 9 times 2 is 18. Divide both sides by 3, and A equals 6. All right, so now I know 6 is right there. Okay, so now you need to cover it up, Okay, if you want to cover up that part you just did, that's fine. Because now you have 2 and 4, and you have 3 and B. Same exact thing. 2 and 4 could be your constant. 2 over 4 equals 3 over B. Cross multiply to get 12 equals 2B. Divide by 2, and B equals 6. So you could write that one here, 6, okay? Now you've got to find C, which is okay because we just solved there to know that this is 6. So 4 and 3 would be my constant, equals 6 over C. Cross multiply. 18 equals 4C. Divide both sides by 4. Yes, sometimes you'll get a decimal. I know you guys always ask me that. Am I going to get a decimal? Okay. Well, sometimes you will. 4.5. All right. Now, there's also proportions with angle bisectors. It's been a while since we did angle bisectors, so this gives you a good visual, okay? But if a ray bisects an angle of a triangle, then it divides the opposite side into segments that are proportional to the lengths of the other two sides, okay? So what they're saying is this. As you know, this ray splits angle A into two congruent parts. That's what a bisector does. It splits it into two equal parts, okay? So now this has been divided. And what they're saying as far as proportionality is concerned, and it tells you right here, so I'll read this to you and then I'm going to explain to you what that means on the diagram. If triangle BAC, that's this one, BAC, is congruent to triangle CAD, that's this one, then BC over CD, BC over CD, this one over this one, that's what that says, is equal to AB over AD. So in other words, this one over this one is equal to this one over this one. So in other words, the top over the bottom, the top over the bottom. And then you're able to set up a proportion following that guideline. So you might want to circle that. Just remember top over bottom, top over bottom. And that's the way you could set that up to solve for any missing measure. All right, so let's take a look now at example 8. Let's see how this works, okay? We have 21 and 9 and x and 14. So remember what I just said, top over bottom, top over bottom. And that's exactly how you would set that up. And then just cross multiply. 21x equals 126. Divide both sides by 21, and x equals 6. Very good. All right, now to do example 9, same thing. Top over bottom, top over bottom. And this time we're going to be solving for x. So 5 over 3 equals 4x plus 1 over 15. Just think of that as distributive. Take your time when you cross multiply. 3 times 4x plus 1 would be 12x plus 3 equals 5 times 15 is 75. And then you just work it like a regular equation. 12x equals 72. Divide both sides by 12, and x equals 6. And there you go.